Okay, we're going to get started. Let's do a quick sound check with the presenters. So Chelsea and Brad, can you hear me?
Yes, we can.
Yes, we sure can. Thanks,
Terrific.
Mark.
Terrific. Great. All right, let's get started. I'd like to thank everyone for attending. Today we're going to be talking about solar hybrid fuel cells for remote critical power applications. This is a joint webinar between SFC Energy and Morningstar. SFC has been using Morningstar controllers in its kits for many years, so we're very happy to have them join us today. This presentation should run about 30 minutes, and then we'll handle questions from the audience at the end. We can go to the next slide, and we'll just show you a mock-up of the GoToWebinar console. So if you have a question, just go ahead and type it into the questions chat box at the bottom of your GoToWebinar pane. I will address your questions at the end as time permits. And I also should note that we've attached a copy of the slide deck that we're using today, and that's in the handout section of your GoToWebinar pane. So you can go ahead and download that right now, as well as 3 data sheets that might be of interest to you. All right, lastly, I should say that we are recording this broadcast, and we're going to email you a link to the recording before the end of day tomorrow. And you can see today's presenters. We have Chelsea Kovacs from SFC Energy and Brad Burwald from Morningstar Corporation. Now, before I hand off to Chelsea, let's go ahead to the next slide and let me take 30 seconds to introduce everyone to Morningstar. You can see here that Morningstar is a U.S. company that was founded in 1993, and we've been a leading supplier of solar charge controllers and inverters throughout the world. We conduct business through authorized distributors, and we're considered to be the charging experts with the lowest hardware failure rate in the industry. And over 4 million Morningstar controllers and inverters have been supplied for all types of industrial, mobile, and residential applications. So with that said, let's go ahead to the next slide and let Chelsea take herself off mute and tell us a little bit about SFC Energy and their solar hybrid fuel cell systems and case studies.
Perfect. Thank you so much. All right, welcome everybody. So SFC Energy, if you're not familiar with us, we are a fuel cell manufacturing company. I am through an acquisition, so we used to be Simart Controls. We were in the industry for over 50 years, and in 2013, we were acquired by SFC. So we're a global organization, and we're based out of Germany. That's where the fuel cell technology itself is actually manufactured, and you're dealing with the North American division here. So for us, our integration facility is going to be located in Calgary, Alberta, and we've got different offices across Canada, Edmonton, Grand Prairie, Montreal, and we're actually just expanding into Toronto right now as well, which is quite exciting for us. So one thing that we're most proud of is the number of fuel cells that we have installed. If you're familiar with fuel cell technology at all, you'll know that I wouldn't say that it's a new technology, but it's certainly cutting edge, and we've got over 50,000 internationally, which means that we're producing up to 6.5 million kilowatt hours of energy. This just kind of gives you a different understanding of our company. We offer hydrogen and methanol fuel cells, and really what we're helping do is we're bringing climate neutral energy to the marketplace. So if we look at the 2 different types of fuel cells that we offer, what I'll quickly do is I'll just give you a high-level overview of how we produce power, package power, hand it over to Brad, and he'll give you a rundown of the charge controller and how it integrates into our packaging, and then I'll wrap with just some application examples as well. But fuel cell technology, one thing that's important, regardless about if it's a methanol-based fuel cell or hydrogen-based, we are producing power through a chemical reaction. So there's no combustion process, which means that we are extremely eco-friendly, and we're not producing harmful emissions. So on the left side, this shows the chemical reaction on our methanol-based fuel cell. Energy input is going to be ultra pure methanol, so it's 99.99% pure. And energy output is going to be DC power, a small amount of carbon dioxide, similar to a human breathing, waste heat, and a small amount of water vapor as well. And then if you look on the right, then we have our hydrogen fuel cell. So very similar principle. Again, this is a chemical reaction. Hydrogen is the energy input. And then with this technology, there's actually 0 carbon footprint, which is quite nice. So we're displacing a lot of diesel generators with hydrogen fuel cell technology. that kind of gives you an understanding of how we produce power. When we get into the different models and units that we offer, this just gives you an idea of our product line. So if we look over on the left, the units that you see that have a white casing around them, these are what we call our consumer line. And so these are intended to be installed in boats and RVs. Then when we look into the middle, the gray units, this is going to be our Industrial Pro series, and that's where I'll spend the bulk of my time talking about today. And then on the far right is actually when we have our hydrogen fuel cell. So the smallest unit that we offer is going to be 40 watts of power. The largest single unit, with the exception of hydrogen, is 500 watts of power. So with fuel cell technology, you can parallel multiple units together to meet rated power. So when we're sizing and designing our systems, that's what we're really looking at is what your average continuous load is. And you might end up seeing us parallel two of our Pro 2800 series together to meet 250 watts continuous. Or we might even be paralleling our Pro 12,000 units that producing 500 watts. If we parallel two, then we're looking at 1 kilowatt of energy. When we get over to the hydrogen fuel cell, each fuel cell module is going to produce 2.5 kilowatts. And again, it's scalable. We'll stack multiple modules together to meet rated power. This just gives you an idea of how we package our solutions, because producing power is just one piece. The way that we deliver and bring power to our clients is through our packaging as well. So if you look at the left, these are going to be cabinet-based systems, and these are stationary. You'll see these typically around the oil and gas industry is going to be a large user, for example. And then in the center, these are going to be our mobile trailers. And these are for clients that obviously need the ability to move their power system around. So for example, the mining sector might be using this to monitor the haul trucks on an open pit mine. And then in the far right, this is an example of our hydrogen fuel cell. And this is one of our, we call it the X series cabinet. And this is an outdoor solution where you've got the hydrogen supply located right beside the fuel cell modules. And this is really where we at SFC specialize, is bringing fit for purpose solutions integrated with our fuel cell technology that's designed specific to the application and the environmental extremes that that area where it's being installed might be subject to. So what this is doing here is if you look at, let's just say that you have a solar system and you're tied into batteries, is when you've got a load, it's going to pull off of your batteries and it's going to discharge. But what the fuel cell is designed to do is it's monitoring the state of charge on your battery bank at all times. So it's looking at your voltage set points. So really you can think about the fuel cell technology as a smart battery charger. So what it's going to do is it's going to keep your batteries at an optimal state of charge. It's going to prevent deep discharge, and it's automatically cycling on and off based on battery voltage. So there's no user intervention. Once your battery's discharged to, let's just say 50% depth of discharge, the fuel cell turns on, it'll carry the burden of the load, it'll bring your batteries back up to float, and then it's going to go into standby mode and just wait for those batteries to drop again. So essentially what we're going to do is we're going to give you the maximum life out of a battery bank that you possibly can, because we are going to protect it from extreme cold weather and deep discharge. When you look at how we size and design our energy solutions, fuel cell technology is the perfect complement to solar. So typically what we're going to do is when we're designing a system, we're going to look at what your average continuous load is, and then we're going to factor in solar input. So if it's a system, let's just say installed here in Canada, sometimes during the winter months, solar resource is challenged and you might experience some downtime. So the fuel cell is going to be supplemental power. We're gonna lead with solar, and in the event it can't maintain that charge on the battery bank, you've got the fuel cell there as reliable backup. So when we're sizing these systems, we always size them to be fully redundant as well. Let's just say your solar panels, for example, walk away from site. The EFOY will carry the full burden of the site loading so that you don't experience any downtime. The trade-off is just going to be a little bit more methanol consumption than maybe we first projected when we originally sized the system. The graph that you see on the bottom left of the screen is a hybrid calculation. So anytime you come to us for a system proposal, what we'll do is we will model exactly what we think the fuel cell is going to do. So we're going to take into consideration your loading, the location that you're installing the system, and we're going to give you a projection on your annual runtime hours and the liters and the cost of the fuel that you're going to be consuming. So really, we're able to give you a really nice expectation for your annual operational expense, and I can plot this out over 10 years as well. One of the other key features of fuel cell technology is the fact that it's got remote monitoring capabilities built directly into the firmware. So depending on which model of fuel cell you're looking at, one of them is Modbus RTU, the other one is Modbus TCP, but this gives you the ability, if you're an oil and gas client, for example, to pull all of the EFOY alarms in through your SCADA, or you can use a cloud-based system like what you see on the screen here. And really, this allows you to remotely monitor and control the system. So you can set low fuel alarms, you can get error codes, because the whole purpose of having a fuel cell integrated into your solar setup is to give you the reliability and also take away as much user intervention as required. And I'll hand it over to you, Brad.
Okay, great. Thank you very much, Chelsea. We appreciate the overview there. And again, as Mark introduced me, my name is Brad Burwald, and I'm currently Senior Product Manager at Morningstar. So I work with the development team and also on a lot of our upcoming products and also on collaboration, such as these types of unique applications. So really pleased to participate with SFC. And in my portion of the presentation, what I'd like to do is talk a little bit about our charge controllers and their role in these hybrid systems, because I think what you'll see at the end of this presentation is, utilizing the best strengths of both of these products together really gives you an extremely reliable and cost-effective system, to keep your loads running. So the charge controller's role, just at a high level on this slide, is really to regulate power coming from the solar modules to the battery. So it is also a charger of sorts, but in DC only terms, it is taking the DC power from the module and providing direct charge output to the battery as well as to the loads. It's all, one circuit. And with that comes a variety of models, which I'll be talking about here shortly. And those specifications vary greatly depending on how much power you need. So we've got a variety of ratings in output amps. We have different VOC ratings, which is essentially the highest voltage that the controller can accept on the PV input. Depending on the way the module is configured, there's a few different ways in which you can do that, but there's quite a few that make it easy to size. And then of course we support standard DC voltages of 12, 24, and 48 volts. So most all of your industrial DC-based remote power needs can be taken care of. The product also includes a variety of electronic protections. It's really situated right in the middle of the power flow there, so it's able to keep track of not only the battery and the PV state, but also a variety of data, as well as preventing any kinds of errors. So it will protect from short circuits, reverse polarity, excessive power by limiting the current if needed, and also monitors temperature very closely. And then you can see in the photo there, your loads would be powered directly by the charge controller, and these can be a variety of DC load applications. Okay, next slide, please, Chelsea. So a little bit about the different models. We're going to focus on just a couple here because they're most commonly paired with the fuel cells in these types of applications. The first is our ProStar, and this model comes in both MPPT as well as PWM variants. And this product has a long history. Currently, the third generation of the product. It's been available in the market and relied upon for many years in a variety of applications. The ProStar MPPT and PWM there are featured respectively above and below, and they handle power outputs as high as 1100 watts, and that's the continuous power rating to the battery. Many times the solar modules can actually be sized greater than the capacity of the controller, and it will automatically limit that. So it provides a even better sizing benefit there if you want to put more PV in than the controller can handle. It's used to the cooling of the product is achieved through just convection cooling. So there's no fans, no moving parts. There's not any kind of ingress of dirt or other contaminants. So you'll see, smooth and quiet operation. And also, of course, fans in many cooled applications, provide a parasitic load on the system. So we've got a very low self-consumption for the product as well. And you can see on the right there that we've even received additional certifications from different labs around the world for use in a variety of applications, some even hazardous location rated. So next slide, please. Now the TriStar, also available in MPPT and PWM, is a much higher capacity product than the ProStar. It's really been a key product for not only large industrial systems, but also telecommunications, such as in the photo on the right. And it is able to handle capacities of up to 3 kilowatt peak power delivered to the battery per controller. And the controllers often can be paralleled for much greater capacity. And just as I mentioned earlier with the ProStar, they can be oversized with larger arrays. Then they will automatically current limit if you do want to add a little more redundancy. Again, extensive built-in protections and a completely fanless design, which is a bit unique on products of this size because it is handling quite a bit of power into the battery. But again, high efficiency paired with an industrial heatsink allows for cool operation and reliable. Next slide, please. So some of the industrial rated features that are kind of common across all of our product lines, including the ProStar and TriStar, are first that we can work with a variety of battery chemistries. So you'll see that obviously lead acid has been a standard for many years, but lithium and variations of lithium cells are more commonplace in the industry. Even unique batteries such as nickel cadmium can be charged. So we have a variety of standard set points as well as the ability to completely customize the charging profile for any type of battery. Large capacity and the ability to parallel the controllers is standard. All of the MPPTs utilize our TrackStar technology, which is a unique form of MPPT tracking that Morningstar has developed, which gives you a very fast reaction to changing PV temperatures, sunlight levels, and is really going to maximize the output under all conditions. And also with MPPT, the unique ability to accept higher voltage PV and charge a lower voltage battery, and the PPT will actually do the power conversion for you. The peak efficiency of 99% is actually an industry leading figure that really just ensures that more available power is getting to the battery, and the less efficiency loss you have, the less heat is generated, and that's going to really increase the operating life in the long run. Temperature ranges -40 to +60, and that is for its full power rating. In the excess of temperature inside a cabinet, the product will automatically limit current. It will not shut down, but it will just reduce current to a more acceptable level for the time being. And then lastly, you'll see that we do back the products by an extremely strong warranty of 5 years and really have a 15-year life expectancy for most of the products. Next slide. Now, a little bit about the insides. We'd like to talk about the technology that we've really developed over the years in making up the current 3rd generation line. And you'll just see a lot of unique design attributes under the hood, some of which are very high frequency control, multi-phase. You'll see 3 actual stages on the left that work together in conjunction to provide maximum efficiency. We have built-in lightning protection on all of the products, and we take the extra steps with design features such as corrosion resistant terminals. We make sure that there are plenty of available communication ports supporting a variety of products, which I'll talk about shortly. And we even use some unique products such as our direct FET MOSFET system that allows really good contact with the heat generating portion of the design and the heatsink, because it's really not just about having a vent to let the heat out, it's more about getting the heat out actively of the product, and that requires a good mechanical design. Next slide. Now here's an internal look at our TriStar MPPT controller. A lot of the same attributes. You'll see a notable feature in the middle there. It's like a kind of a fin-shaped spikes in the inside there, and that is our spring FET system, and that's what I was referring to earlier, is the heat conduction portion of the controller that gets the hottest is actually in direct contact with the heatsink, and we keep it in place using that spring system, and that ensures throughout a wide variety of operating temperatures that it's always going to maintain optimal cooling, because cycling between sub-zero temperatures and extremely hot temperatures, it can take its toll on products, so we have to design that in mind when we build the product. And then there's several other unique features of the product you can see here. And this product also does include the same 3-phase technology. So our 60 amp product is actually 3 20 amp phases that are working together, and they will turn on and off as needed, sort of like a gear system in a vehicle to increase or decrease power depending on the needs of the battery and the PV system. Next slide. So as I mentioned, Morningstar offers both of these types of controllers. PPTs are probably featured more prominently as the more efficient and provide the most power generation, and they also work with a variety of modules, especially those of the higher voltage variety, that typically come from, the global direction that the grid connect market is taking. But we also do offer PWM charge controllers, and those are sometimes simpler design, a lower cost one, but important nonetheless in small systems where a simple 1 or 2 module system is deployed, and it's still designed with the best type of quality and reliability, but just with a simpler charging circuit. So PWM works well in a variety of locations, especially high temperatures, and has been a mainstay in our product line since inception. Next slide. But with MPPT, you'll see some of the benefits are more delivered power, more ability to use the modules at their peak operating point, which equals better production or harvest, as we call it, and also more overall reserve power because you don't lose a lot of that, wasted energy. So, and with today's modules exceeding 400, 450 watts peak, we need to make sure that the products are nimble and able to accept all of those voltages. Next slide. So one comment on connectivity, all of Morningstar's product lines that are destined for these types of industrial applications have a variety of data options. And as Chelsea mentioned earlier, we also do utilize the Modbus communication protocol. It's extremely common in SCADA and industrial automation, namely energy monitoring. And of course, both RTU as well as IP-based connectivity options are available for our products. And that's what makes them especially well suited for this application, because data can be collected using a remote monitor and IoT systems for both the solar charge controller as well as the fuel cell. And a lot of integrators, those in special applications, do appreciate that ability to interoperate with the equipment and collect data for their own diagnostics and power data, power reporting on those measurements. Okay, next slide. So one of the things that is important to discuss is that we, namely with the ProStar, you'll notice that it does have load control available as well. And that means it will manage the load output and make sure to keep an eye on that. In the event of a very low discharged battery, there is the ability of the controller to disconnect the load. However, because of the combination of a well-sized system, based on solar levels, as well as having the fuel cell available to make up for any deficits, it's really, all but eliminated from the system. But if you do ever get those deep discharge, the controller will actually disconnect the load in order to save the battery from damage. And then an automatic reconnect will occur once the battery or the fuel cell have brought the voltage back up to a healthy level and reconnect. And that's really to keep that battery from, going into what we would call a brownout stage, where the battery is so low that there's a possibility that you can actually not power your equipment. So all that is protected and the energy is preserved in the battery. And as Chelsea showed earlier in her graph, you'll actually see that between the solar and having the fuel cell, the battery is kept at a very high state of charge. So not only is that a more reliable operating window to stay within, but it's also going to make the battery last much longer because it's being cycled in a very shallow manner, and that's really going to extend its life. Next slide. So just a few things to cover here, because one of the reasons we're co-presenting today is to talk about the benefits of solar hybrid systems with fuel cell technology combined in one. And just wanted to make some notes here on some of the really useful benefits that come from this. First of all, the solar use, the energy source that's delivered from the sun for free at the site is the one you're going to be taking advantage of, and that methanol is going to be stored only when needed, of course, because it does have to be refueled, and of course the solar is always prioritized above that. So you'll see again on that operating graph that Chelsea showed, the solar controller will work in that upper band, and only if there's extreme load usage or insufficient sun, possibly after a couple days, will that be required. So that methanol is consumed only when the solar is insufficient, for a longer period of time. And that really makes the autonomy, virtually limitless, only on your available fuel, based on the runtime. Performance and diagnostic data can be collected from both sides of the system, the fuel cell and the controller, as I mentioned, both being able to communicate with Modbus. Your battery state of charge is really going to be kept in a high band. So your battery cycle life, while it may be rated for 80% depth of discharge, if you're at half or even a third of that, you're essentially going to be double or more of the lifetime, because the number of cycles has been greatly reduced. It's extremely beneficial in cold temperatures. And namely, if one of the competitive situations is utilizing a gasoline or diesel generator, you'll find that the methanol fuel cell and solar will work, reliably in even these cold temperatures. And you don't have to worry about oil or starting problems or anything that impacts, a typical combustion engine. And as I said, that loss of load probability is virtually eliminated. And of course, with the data, you'll have very good insight into exactly what's happening with the system so that anything can be addressed well in advance. We hate it when a customer will tell us, well, I knew there was a problem because my load disappeared. By then it's too late. You want to be able to get on it ahead of time so that you can preserve that operation. And then lastly, I think that the fuel cell is a perfect technology with solar in this case because its ability to have a variable output, it only consumes as much fuel as possible. If you've looked into generators a lot, you'll see that they really require a sweet spot of a lot of power for them to work reliably and to be sized correctly, whereas a fuel cell is quite variable. It can deliver a little or a lot as needed, which makes that a much better fit for solar systems. Okay, so with that, I will hand this back to Chelsea. Thank you.
Perfect. Thank you so much. So this right here just gives you an idea of some of the different industries that fuel cell technology services. So really what we're targeting here is remote applications that are going to be installed in locations where traditional utility infrastructure is not available, or perhaps the loading is so low that it doesn't make sense from an economics perspective to bring in utility power, or it could just quite simply be a mountaintop location where that's not an option. So I'm going to walk you through a couple specific examples of some of the different solutions that we've deployed, and I'm going to focus a little bit more on the mining segment and telecommunications. So when we look at the mining segment, I mean, mines are located in extremely remote locations. They're far removed from traditional infrastructure, and power is a significant problem. A lot of the time you're going to see diesel generators being used because there's not a lot of options that can perform in some of these harsh environments. And so the fuel cell is a really great way for clients to come in and reduce their carbon footprint, but most importantly, reduce their annual operating costs by using fuel cell technology. So you'll see us powering security and surveillance, access control systems, environmental monitoring, rail and signaling, and telecommunications. In the picture that you see, that is actually an SFC trailer solution. And so what we're doing is we're providing power to the communication equipment and the cameras that are monitoring haul trucks on open pit mines, and we're communicating that data. Why they like using a hybrid setup in this setup is because we're sizing the solution so that they're getting about 1 year of refueling autonomy between solar and the fuel cell, and they're getting away from these carbon taxes, and they don't incur a heavy operational expense. Just for an example, we have a client out in Eastern Canada that visited site 52 times a year for his gensets. Once he replaced that generator with the fuel cell technology, he went down to, I think it was just 1 or 2 visits. So he eliminated over 50 trips to site, which was a significant cost savings. When we look at telecommunication sector, this is serviced by our methanol fuel cell and our hydrogen fuel cell. There's 2 different areas that we'll play into, one being backup power. And so really what we're doing is we're just providing power in the event that utility is cut off. Let's just say it's an emergency. And instead of relying on your batteries, you're going to have that fuel cell technology there as your power generation. So basically we'll top up those batteries. You see in the graph here how we're connected. And then as soon as utility power is back online, that fuel cell is going to turn off. Generally, we see these systems being sized for at a minimum 72 hours of autonomy, sometimes extended further as well. When we look into hybrid or a remote communication tower, as an example, we're looking at providing primary source of power. So this is really where we're going to use the fuel cell in conjunction with solar. Some clients want us to integrate wind as well, and that's really where, instead of tying the autonomy to a battery bank like you typically would in a standalone solar system, this is where we're going to rely on the energy density of the fuel that the fuel cell is going to consume. So for example, let's just say it was a mountaintop repeater site. Their load was 50 watts continuous. If we provided 2 28-liter fuel cartridges, that's going to be about 1 month of autonomy in the fuel alone. And that's not factoring in anything that solar is going to contribute as well. So when we're sizing and we're designing our solutions for our clients, we're taking into consideration their desired autonomy that they're looking to achieve at these sites, because we can scale that with the fuel. And lastly, this just gives you kind of an idea of our installation base. Again, fuel cell technology is not new, it's quite mature. And we are actually one of the only profitable fuel cell companies in the world. And I believe this number that you see here is actually out of date. We're probably closer to 55,000 energy systems globally and about 1,500 in North America. And just keep in mind that 1,500 would have been accomplished over the past 4 years since we took on the technology. Just to give you an idea, again, just reiterating some of the benefits of using fuel cells to integrate into your solar is just the reliability. We're allowing you to lead with solar as your primary source of power, and you're not sacrificing any operational efficiency. Again, methanol specifically has very high energy density, which allows us to extend our autonomy and really scale specific to the loading and the location. Just speaking to the maintenance side of fuel cell technology, they're designed to start and stop until the end of life. So there's no oil changes or filters that need to be replaced. The fuel cell technology itself is preventative maintenance free. The packaging, how you're going to transport that and deliver it to site, there might be a PM schedule tied to that. But very low maintenance, very low operational expense. And again, they're designed to work in various environmental extremes around the world. And we've proven that with our global footprint. So I just want to thank everybody for your time. And Brad, thank you so much for co-presenting with me. This was fantastic.
Great. Chelsea and Brad, thank you very much. This is Mark chiming in. We've reached the Q&A session. We do have some questions that came in. So I guess this first question is probably for Brad. A question coming in from Dustin. The question is, he's wondering why the solar controllers do not output voltage until the input gets to a certain limit or a certain level. He questions, isn't this causing a shorter charging time throughout the day? So do you want to go ahead and try to address that, Brad?
Certainly, yeah, that's a good question. The type of controller that we use in DC to DC power conversion terms is a buck converter. That means it will buck or convert a high voltage down to a low voltage. Since modules typically have higher voltages than batteries, between their VMP and the VOC, and that solar modules are often stacked in series, that's the most common application, is a higher voltage input going down to a lower voltage battery. There do exist options of what's called a boost converter, which will convert from low to high, but it's typically not that common. So for that reason, the battery voltage is, you have to get a higher voltage on the array than the battery for charging to begin. Like water flowing downhill, you've got to have that rise on the input side first. I would say, while it does typically take a little bit of time for the sun to rise and to get going, you'll find that voltage will jump up quite quickly. It's not as limited as like a grid tie inverter, which may not produce power until it gets, over 180 or 200 volts. We'll see energy flow start quite quickly. At that point, the sun is low in the sky anyway, so you're not getting a lot of total power availability. So it's not too much of a limiting factor. So I hope that answers your question. And, I would note that we do actually have one of the lowest turn on or activation voltages in the industry. It's just, I think, between 1 and 2 volts above battery voltage for us to start charging. So it is quite effective at charging as soon as possible.
All right, great. Thanks for that question and answer. I see a question for Chelsea here. This is coming in from Joseph. The question is, how pure is the methanol that is required? Is it 90% or is it 99% or is it 99.9%? And then the second part of his question is, will your technology tolerate other fuels besides methanol?
That's a great question. So with the methanol fuel, it is 99.99% ultra pure. And the reason for that is because with fuel cell technology, internal to the unit is the stack. That's what's producing power, and it's quite sensitive. So if you use less than pure methanol or even hydrogen, you're at risk of degrading that stack life at a much more rapid rate. So it's really the reason why we're providing that level of purity is to maintain the integrity of the stack. A lot of the questions that I get, for example, are oil and gas clients. They'll have field grade methanol sitting right by the unit for a chemical pump, and they'll say, like, why can't I use this? And it is just because you will start to foul up the stack at a much more rapid pace. So that's why we try to use ultra pure methanol for all of our installations on the methanol fuel cell. And the same with hydrogen. It is a very high level of methanol, or sorry, hydrogen as well.
All right, very good. I see a question that has come in from Armand. The question is, what is the operating temperature of the EFOY units and the life expectancy? So if Chelsea, you want to go ahead and take that one.
Yep, great question again. So the fuel cell itself is rated to -20 degrees Celsius. And then when we package it into our setup, so for example, if we were doing an outdoor stationary cabinet, those are rated to -40 degrees. And then they're tested down to -60. So we have systems that are installed in the Arctic Circle, just to give you an idea of how we handle extreme cold temperatures. And sorry, what was the second half of that question?
I think that was a one part. He said, let me see if I can see Armand. Yeah, just that one. What is the operating temperature? Oh, I'm
Yeah.
sorry, and the life expectancy. Sorry about that.
Life expectancy. No problem. So that's a good question. So stack life is going to degrade, and so let's just say, for example, you're using 125 watt fuel cell at about 6,000 runtime hours. I would expect that unit to be producing about 80 watts of power. So it really comes down to how we've sized and designed the system, and that's also why we supplement with solar. So we try to aim for a fuel cell to get between 500 and 1,000 runtime hours a year in a setup. And then you're looking at about anywhere from 8 to 10 years of life before the fuel cell might need to be refurbished so that it's producing full power again. But when we model this and we give you your hybrid calculations, we can give you a fairly accurate estimate on when we think that unit will come to end of life.
Okay, very good. All right, I see a question coming in. Actually, Barton had a couple of questions here. So let's see. He's asking, are fuel cells cost effective for off-grid home use? And also, it looks like he has a question here as to whether you provide design assistance or some types of programs to help people out with their systems.
So that one I would say is a little bit tricky. In North America, with the way that our power demands are, I would say that a fuel cell might struggle to keep up with a residential home. That being said, if we were looking at a remote cabin that didn't have AC equipment, then it could be possible. But I would say that you don't see fuel cells in residential applications. I would expect that over the next couple of years, it will be more viable. But it's challenging just because we do require quite a bit of power for a residential application.
Okay, very good. And for those here that looks like Barton also had a question about the cost of fuel cells. Is that something that he should take offline with you and email you, Chelsea, or is there anything more you want to say about that?
Yeah, absolutely. If you've got questions about pricing on the technology, please reach out to me. The fuel cell is just one component. We also have to take into consideration how we're packaging the system as well. So whether or not you need a cabinet or a Pelican case or a trailer, and then how much solar and what model of charge controller we're integrating. So there's quite a bit that goes into our solutions. So it's hard for me to throw out a price.
All right, and I see Bernard has a question as to whether there is any type of calculator that he might use to help him in designing small solar fuel cell hybrid systems.
Yeah, you bet. I mean, if you go to one of our websites, it's EFOY-pro.com. There will be an energy calculator there where you can kind of select, you can input all of the loading that you have, and then I believe it gives you drop-down menus for locations to model solar. But that's also a service that we provide to you anytime you come to us for a proposal, as well as we will do, we'll have our engineers review the sizing and the design as well.
Okay, very good. And I see Derek had a question. Looks like it's a pricing question. So he's wondering if you offer budget pricing for these systems. So again, I suspect that's something he could just email you about.
Yep,
And you could,
absolutely.
depending on what he's looking for, get him a precise answer to that. All right, let's see. Looks like Tom has a question in here that says, let's see, I can see the advantages of the systems. Do you also have closed loop fuel cells so you don't have to refuel it?
That is a really good question. Right now, we don't have the closed loop fuel cell. The closest thing that we could do is if we were to integrate an electrolyzer in with our hydrogen fuel cell so that you're producing your own hydrogen on site instead of bringing in bottled hydrogen. But that was a really great question.
Okay, very good. Looks like Charles has a question. Let's see what he's asking here. Okay, let's see. If the batteries are full and the load is met, is it possible to divert excess solar energy to a specific load based on temperature control, for example, room temperature? So I don't know if Chelsea or Brad wants to handle that.
I could comment on that. Yeah, this is a common request. It's an interesting one because if you've got a surplus of energy, your batteries are full, the fuel cell is currently, at rest, and the load is being met, you've got extra energy available. So can that be used for other purposes? We do offer a variety of relay-based control options and accessories with our products, and I've sometimes seen them used for this reason, either to transition energy when a battery is in absorption or float, to make a voltage-based switch to run something else, such as heating something, or even converting energy into like an electrolyzer was an interesting application that Chelsea had talked about. So that is a possibility. It just really depends on if the system was sized to have that much extra energy anyway. It may be a little bit over designed, but it is an option. So, and then lastly, this is another area where the monitoring comes in handy, because maybe some control can be used to make these types of decisions if you've got extra energy. So yeah, take a look at our website. Our relay driver products could be an option as well.
All right, very good. Looks like we have another Brad question here. Do MPPTs support solid state batteries?
We are always looking into different types of battery options to support with our products. I would say that if you look on our website, we have our battery energy storage partner program that currently has a lot of discussion and configuration, providing support for a variety of both lead acid, lithium, and even other alternative chemistries. I know solid state batteries are currently being aggressively pursued because of their many advantages. We have not encountered anything in the market like that is commercially viable for support today, but there's no reason it couldn't in the future. And I'd imagine, as we look at, nickel cadmium and even zinc, based batteries, flow batteries, that I hope that would be something in the future. Most of them come down to a software configuration, and we've got a pretty powerful charge profile set up on our products. So we hope that, it would be an option.
All right, very good. I see a question from Ray, and this is for Chelsea. Question is, do you have a 10 kilowatt system available? I don't see specs for higher than 5 kilowatt.
So for 10 kilowatts, what we would do is we would parallel the hydrogen unit together to meet 10 kilowatts. So yes, it is possible, because again, each fuel cell module on the hydrogen side is producing 2.5, and I can hypothetically scale up to 50 megawatts.
All right, very good. And let's see, Bernard has a question. Looks like this is a question for Chelsea. How can we explain to potential customers how and when low maintenance costs can outweigh high acquisition costs? Is there a typical example?
That's a great question. I think from my perspective, I would want to understand what they're currently using for power generation and just get an idea on the downtime so that we can kind of correlate the return of investment. Um, I mean, fuel cell technology comes at a higher capital cost than standalone solar, but when we look at the operational expense, I mean, depending how we've designed the system, you could go out to site once a year to replenish the fuel cartridges. That could cost as little as $400 annually, compared to a client that might be running, let's just say, a propane-fed thermoelectric generator where they're maintaining a bullet constantly. That's coming at a very high cost. So it's helpful for me to understand kind of what we're being compared against, and then again, I can plot out the operational expense. So I hope I answered that question. And if I didn't, please just message me and we can talk a little bit more about your application specifically, and I can give you some tips or questions to ask your client.
All right, questions are coming in fast and furious. We have a question here from Ray who asks, how many 5 kilowatt units have you installed in the United States?
So the hydrogen fuel cell is a new technology for us in North America. It's a mature technology in Europe, so I would say that we've got about 1,000 installed in Europe, but we're looking to get our first pilots in North America this year.
All right, very good. Let's see, a question here for Brad. Are the Morningstar controllers compatible with flooded nickel cadmium batteries?
Yes, we do have support for nickel cadmium. They typically have a little bit different voltage per cell, and there are usually more cells in the bank configuration, and they also have a slightly different temperature compensation coefficient that is applied versus lead acid, but all of those things can be changed in the software profile for the battery. So yes, we can actually support nickel cadmium batteries. And just one additional note, since this came up previously on the solid state battery, for those interested in the latest with battery technology, we are currently just wrapping up support for even a supercapacitor product as well for charging. So definitely a lot happening on the storage front.
Okay, and it looks like this question is for Chelsea. The question is, what is the voltage for a single cell?
So the fuel cell modules come in 12 or 24 volts. 500 watt unit is in 48 volts, and we can integrate inverters and converters when needed.
All
Native
right,
voltage is DC though.
very good. Let's see, I guess another question here for Chelsea. What is your energy conversion efficiency for the units?
That's a great question. I believe that we are over 33% efficient, but I'd want to fact check myself.
Okay, very good. Let's see. All right, Sarah's asking a question. What is the expected maintenance schedule and actions of these fuel cells for a remote site?
So again, the fuel cell itself, there's no preventative maintenance that you'll need to do. You just need to replace fuel cartridges when prompted by the low fuel alerts. Let's just say that you've integrated that fuel cell into an outdoor cabinet system. One of our packages, let's just, again, reference a mining client. For example, it's a stationary system integrated in the cabinet. If we've sized it for annual fuel autonomy, you'll go out once a year, you'll replace the 2 fuel cartridges that take less than 10 minutes. It's very simple to replace fuel cartridges. And then the only other thing that we would recommend doing is just doing a health check on your battery bank, make sure that they're still in good working order. And then you want to look at the exhaust spout on that cabinet and just make sure that it's clear from debris, because part of the chemical, one of the byproducts in the chemical reaction when we produce power is a small amount of water vapor. So you can imagine that water vapor and extreme cold temperatures can cause ice to start accumulating on the ground where that exhaust is venting. So we just want to make sure that it's cleared. But in our package, we also put that exhaust line is going to be fully heat traced to prevent any freeze up as well.
All right. Another question for Chelsea here. The question is, can the EFOY fuel cells be used? I think you touched on this a little bit earlier, but can the fuel cells be used with an off-grid 48 volt vacation home system?
They could, yes. It would just, you'd want to look at the pricing, or not necessarily the pricing. We'd want to look at the economics on the methanol fuel supply to keep up with that demand.
All right. And then a question here about approximately what is the price for the ultra pure fuel per gallon?
So I'll reference on a 28-liter fuel cartridge, it's going to be around $200 Canadian, and that's just for one.
Gotcha. Okay. Takes care of that. Let's see. Question here from Ray. On the hydrogen solution, what is the capacity in grams or kilograms for each tank?
That is another great question. So this is where we would probably look at, I don't know if I can properly answer that, because what we're doing is we're not necessarily providing the hydrogen supply on the hydrogen fuel cell. We're going to partner with someone like an Air Liquide, and they're either going to provide you with bulk cylinder packs that come in a variety of different sizes, or a tube truck. But connect with me after this, and I can give you a better response.
Okay. And looks like a question here about, let's see, this looks like a question for Chelsea, I believe. Looks like this gentleman is living in the Southwest where temperatures reach 130 Fahrenheit at times. What is the maximum operating ambient temperature for these units?
Yep, so they'll perform in 55 degrees Celsius. What we do is, for example, one of our packages, it's a high heat cabinet that we designed for our client down in Texas. It's got fans that are integrated into the setup as well, so that it can disperse any heat if the fuel cell starts to get too hot. So the other thing I guess I didn't mention during this presentation is that the fuel cell has thermostats integrated into the stack as well, so it can monitor its own temperature. So it'll trigger fans to turn on if it starts getting too hot, and it'll run an anti-freeze mode to warm itself back up if it senses that internally it's starting to get cold. So with our packages, we do design for temperature control, just because I can certainly appreciate that while in Canada, we might want to keep the heat in and we want to keep our systems warm. That's going to be the exact opposite down in somewhere like Texas.
All right. And Tim is asking where he can purchase an EFOY in North America. So I again presume he would just be best to email you, Chelsea, and he can
Absolutely.
specifically what areas or area he's looking for. You can handle that. That's terrific. Thanks for that, Tim. Let's see. Mike is asking a question. Do you provide stamped engineered drawings for your proposed designs?
Yeah, at the end, when we've completed the project, you will get a full stamped package. Actually, I don't know if we default to getting a package stamped. We do have professional engineers on staff, so we can supply that as an option, but you do get a full drawing package, and it is a complete CSA certified solution.
Okay, very good question here coming in from Ray. Let's see, do you have a case study of business or a business case for off-grid comparing a diesel genset versus a PEMFC?
I know I have a video that compares the methanol fuel cell. I have some content that I can follow up that definitely compares a genset to a PEM fuel cell. I'm not sure if it's on the website, but I can, if you want to send me an email, I can share that with you over email.
All right, so very good. Thanks for that. Another question coming in, is there an application of wind turbine with fuel cells backup?
Yep, we've integrated with wind for sure. The only challenge that we have is that sometimes wind can be somewhat unpredictable. So when we're sizing the systems, we try to still incorporate solar, and we don't necessarily calculate the wind production just because we're designing for reliability. But again, it's kind of customer specific. A lot of our mining clients like using wind when available, and so we can certainly accommodate that into our design.
All right, and here's a question. What is the largest kilowatt system you've installed, kilowatts per year or month?
That is
Kilowatt
a
hours,
great.
I should say, kilowatt hour system.
So on the methanol side, specifically speaking of North America, like us in our globally, I would say that the largest system is 25 kilowatts on the hydrogen fuel cell in Europe. But speaking more specifically to us, I would say up to 1.5 kilowatts on the methanol fuel cell. And again, we're just getting ready to launch hydrogen, but I'm expecting probably 5 kilowatts and 10 kilowatts are going to be our sweet spot with the hydrogen fuel cell.
All right, very good. And another question for Chelsea. Instead of bottled hydrogen, do you work with any reformers?
Yes, certainly you can do that.
All right, so that takes care of that. That was a question from Bill. Let's see. Here's a question coming in that says, is there a free design program to optimize solar battery generator fuel cells?
Say that there's a free program, but there's a calculator on the EFOY Pro website that you can utilize as well.
Okay, looks like we're coming up close to the hour. How's everyone doing here, Brad and Chelsea? You have a few more minutes?
Yep.
Yeah, certainly. We're getting fantastic questions, so
really
as long as we're able to handle it, let's keep going.
Okay, so let's see. All right, the question is it a separate device that handles the switchover from batteries to fuel cells? She says she missed that if it was mentioned in the presentation.
Nope, you connect the fuel cell directly to your battery bank, and then it's looking at the voltage set points on that battery bank, and that's what's telling it to turn off and on.
All right, very good. Let's see. Okay, perfect. Yes. Question here. Can the exhaust spout be covered by snow for several months, or does it need to be free at all times?
It's tricky. I would say that we'd want it to be free when possible, but I can understand that that's not always the reality versus expectation. The only harm that I can see is if it's covered for an extended period of time, is that it is going to freeze and it could eventually reach the fuel cell, because there's an exhaust line that's coming out of the fuel cell that's running through the heat tracing. And then that's being directed outside of the enclosure. So if it was really caked in ice, the EFOY might error and tell you that it's freezing.
All right, thanks for that question and answer. Another question coming in asks, can portable units withstand vibrations and shocks when transporting on country roads in a motorhome?
You bet. Yep. I mean, we've got systems that are installed in you're gonna laugh, I always say this wrong, but buoys that are out in the ocean. And then we've got a very large fleet of trailers that are getting pulled all around the country. So it's, yeah, the fuel cell technology can definitely handle that.
All right, and here's a question about hydrogen again. Let's see. Assuming only hydrogen is used in a 3 kilowatt deployment, how long will a cylinder last?
So that would depend on the size of that cylinder. So we would size the cylinder to meet your desired autonomy. And then what we would factor in is if we were integrating with solar, because solar is going to be able to contribute power to the batteries as well. So similar to the methanol-based fuel cell, that hydrogen fuel cell is only going to turn on and consume power as it needs to based on your battery voltage. So it's both fuel cell technologies are load following.
All right, very good. Scott asks a question about the availability in these times that we're going through of supply shortage in, for example, Colorado. And I guess maybe you could address that in other areas of US or Canada. Any issues with supply shortages?
No, I mean, to be quite honest with you, we've had a great year. We've been lucky enough to not really experience any supply chain issues. So it just really depends on the volume that you're looking to achieve. This year, we're expecting to manufacture upwards of 15,000 fuel cell modules in our plant in Germany and can be increased as well.
All right, here's a question for both Chelsea and Brad. How are fuel cells and the solar components within the units, how are they affected by electromagnetic interference or EMP? and can they be protected?
I can speak a little bit on this. I mean, we do not have a lot of significant, measured experience in this, but I would say a lot of the risks sometimes with magnetic interference is the induced current surges that it can cause on wire runs. We do use TVSs, which are lightning and surge suppression devices, directly on the product to protect the product itself, and oftentimes larger system level surge arresters or common mode chokes are used to limit these kind of induced surges in the power lines at the system level with much greater capacity. So there are options to mitigate, surge from that source as well as, from lightning or other impacts. But yeah, not working in the field specifically, I don't have a lot of experience with that. There are options.
All
And
right,
then
very good.
speaking,
Oh, go ahead. I'm sorry,
Chelsea?
Chelsea, go ahead.
no, that's okay. I was just going to say, to be honest with you, I don't know if I can answer that question properly on the fuel cell technology. I know that we integrate surge protectors, but I would actually need to do some homework to properly answer that.
All right, very good. Here's a question again for both of you, but let's have Chelsea answer this one first. So the question is, would the hydrogen systems be safe to use in a Class 1 Division 2 area in the oil and gas areas?
That's a great question. As far as certification goes, I believe right now we're aiming for general purpose installations. But as the product starts to get developed, I can find out if it's possible to achieve Class 1 Div 2 or Zone 2. And then just speaking to the methanol fuel cell as well, it is also rated for general purpose, but because there's no combustion process, we fall under electrical code. And our clients here in Alberta, for example, they're installing us 3 meters outside of the classified area.
All right, very good. And Brad, you want to address that question as well, or anything about Class 1 Division 2? And I recall years ago, a silly marketing manager requested if we could make a MPPT controller that was Class 1 Division 2 rated, and I don't know if that's an impossibility or we've actually
No,
done that.
we listened exactly to you, and yeah, it's here. I would just say that yeah, it's common to have systems. The zone is often very limited in its radius, around the equipment. So you can certainly have solar controllers with the Class 1 Division 2 rating inside the zone. We have many that now offer that, both PWM and MPPT, as Mark stated. Of course, we have larger controllers that have not had it and can easily be put into a system just outside the zone. And as Chelsea said, currently the fuel cell can be located there. So as long as it's in the right location and distance, there's no reason it couldn't be used along with solar for power applications in the oil and gas industry.
All right, very good. And looks like the only last question I wanted to ask is if you could both talk a little bit about how days of autonomy work in these systems. So if you want to take that first, Chelsea.
Yeah, sure. So what we're doing is, instead of putting autonomy into a battery bank like you traditionally would with a solar system, we try to tie our autonomy into the fuel just because of the energy density. So just referencing again, if you had a 50-watt continuous load and you had a 20-liter fuel cartridge, that's about 14 days of power in one single fuel cartridge. And then I can scale multiple cartridges together. So if you compare 14 days of autonomy in the fuel and you look at what that would look like in a battery bank, it's a massive footprint difference and price difference as well. So we really try to size for autonomy as a system, taking into consideration what solar's producing and then what the fuel cell is going to supplement, and then obviously tying the autonomy into the fuel.
And anything you want to add to that, Brad?
Yeah, I would just say it sounds like SFC's got excellent sizing and calculations for really understanding the load and what's required in terms of fuel. I would say if this were autonomy on just an ordinary solar system without a fuel cell, we would look at a number of days, very short, typically 4, 7, or maybe in high reliability up to 2 weeks. But that all has to be done through solar, which may or may not be there depending on the weather, as well as just battery capacity. But having a hybrid system with the fuel cell, the solar could of course manage easily independently, and then during those periods where you have a trough in the power supply, the fuel cell makes up for it. So I would expect, in a hybrid system, many weeks would be possible depending on the requirements of the load. So it takes the worst part of the autonomy, those dire situations where there's no sun and it's cold and you've got high load, and really takes those out of the graph, I'd say, having the fuel cell always available. So it's a great solution.
And Brad, just building off of that, sorry, Mark, depending on how the system's designed, again, like typically we're looking at 12 to 18 months of total system autonomy before clients are going out and replacing the fuel cartridges. So again, EFOY is probably going to do the bulk of the operation during winter, and then it's going to sit dormant throughout the summer and let solar provide power.
Mm-hmm.
Okay, and a quick question here. Are your fuel cell products fully CSA certified for Canada?
You bet, yes.
All right, very good.
As our Morningstar solar controllers as well. Yeah, the CSA 22.2.
Very good. We covered that, and let's see. Well, here's, I guess, another question. If we know about it, I never really thought about this. Should the installation of an EFOY unit in a home be reported to your insurance company?
That is a really good question. I would say probably yes, because you're going to have methanol. It depends on where you've put the methanol fuel cartridges, to be honest with you. If the methanol fuel is sitting outside, I don't think you need to worry about it. And even if it is connected, I don't think there's any concerns there, but just being very risk adverse, I think it's in your best interest to probably notify your insurance provider.
Okay, well, very good. I think at this point we can wrap things up. Looks like we covered all these questions that came in. We had terrific participation. Appreciate everyone that attended with us today. Stay tuned for our next upcoming webinars. Thank you very much, Chelsea from SFC Energy. And thank you very much, Brad. We're going to close things out. We'll see you next time. Take care.
Great. Thank you.
Thanks, everybody.